friends, welcome to my YouTube channel Navigator Updates. If you don't know me, I'm Rakesh again. I'm an aviation enthusiast. In today's session, I'm going to explain what is ISA, how to calculate ISA temperature at a specified altitude, then what's a ISA deviation, what is pressure altitude and how to calculate it, and what's density altitude and how to calculate it. So let's start. So friends, ISA, it stands for International Standard Atmosphere, and according to the ISA, at sea level the standard temperature is how much? 15 degrees, and that's what you already know. 15 degrees Celsius is the standard temperature, or the temperature at the sea level according to the International Standard Atmosphere. So you have to remember this value of 15 degrees Celsius. So this 15 degrees Celsius is the ISA temperature at sea level. Now this temperature, which is at sea level, as the altitude increases, it decreases. And how does it decrease? It decreases at this rate, which is 1.98 degrees Celsius per 1000 feet. Okay, so as the altitude increases, for that per 1000 feet there will be a decrease in temperature by 1.98 degrees Celsius, and this thing is called as lapse rate. LAPSE, lapse rate. So I hope you already know that. So what is lapse rate? Lapse rate is the decrease in temperature per 1000 feet as the altitude increases. Okay. So for the purpose of our calculations, in order to make them simple, what we generally do is, instead of 1.98, we consider this to be approximately 2 degrees Celsius. Okay. So we will assume 2 degrees Celsius, okay, for the purpose of our calculations. That means 2 degrees Celsius per 1000 feet we will be considering as the lapse rate for the purpose of our calculations. So right now you're knowing that 15 degrees Celsius is the temperature at the sea level. Now, if you want to calculate the temperature, that is the ISA temperature at a certain specified altitude, let's say 3000. Okay. Suppose this is the sea level and here is 3000 feet. Sea level. We know that at sea level the standard temperature is 15 degrees Celsius. Okay, that is the ISA temperature. At 3000 feet, what will be the ISA temperature? So if you want to calculate that, let me explain it here. So for calculation of the ISA temperature at a particular altitude, it can be any altitude, it can be 3000, 10,000, 30,000, 35,000 and anything. So I'm just taking 3000. So at 3000 ISA temperature, how much it will be? Okay, it will be equal to 15 minus 15 degrees the ISA temperature at sea level minus, okay, now this altitude which is in thousands. Okay, so generally altitudes you find it in thousands, right? So from this altitude just remove the 1000 and then whatever digit is remaining just take that value. Suppose this is 3, so we'll take this as 3 over here. Okay, suppose in its place the altitude was 35,000, then in that case we'll remove the 1000 and what's remaining is 35. So in that case we'll consider here as 35. Okay, so right now our altitude in our example, I'm not considering it to be 35, I'm considering it to be 3000. So I'll just remove the 1000 part and what's remaining is 3. So 3 I'm considering it here. So 3 multiplied by the lapse rate. What is the lapse rate? 2 degrees per 1000 feet. Okay, so 2 degrees is the lapse rate per 1000 feet. So just make out this calculation. So how much it comes to be? 15 minus 3 into 2, 6, equal to 15 minus 6, 9 degrees. Okay, that means 9 degrees is the ISA at 3000 feet. Okay, so that is how you calculate the ISA temperature at a particular altitude, which is 9 degrees for 3000. Likewise, you can calculate for any other altitude. Let's take example of 35,000. Okay, suppose you are at 35,000 feet. Okay, so if you are at 35,000 feet, just don't consider this 3000 anymore. So if you want to calculate the ISA temperature at 35,000 feet, how much it will be? So the ISA temperature at 35,000 feet will be 15 minus, okay, and this 35, I'll write it here, 35 into what is the lapse rate is 2 degree. Okay, so how much it comes? 15 minus, this is 35 into 2 is 70. It comes to be minus 10 minus 5, 5, 6 minus 1, 5. So minus 55 degrees Celsius is the ISA at 35,000 feet. Okay. So right now we have discussed how to calculate the ISA temperature at a particular altitude, and I hope you're clear with that. Next, let's discuss about the next topic, which is ISA deviation. Okay, regarding ISA temperature calculations, I hope you are clear with that. Next is ISA deviation. ISA deviation is basically how many degrees the actual temperature at a particular altitude varies from the ISA at that particular altitude. Okay, so let us understand that. So how to calculate the ISA deviation? In order to calculate the ISA deviation, okay, there is a formula, okay, which is ISA deviation, which is equal to OAT at that particular altitude. Suppose it's 3000, then at that altitude what is the temperature that on that particular day? Okay, so OAT, which is the actual temperature, minus the ISA temperature at that particular altitude. Okay, so it means the actual temperature minus the ISA at that particular altitude. Let's take an example to understand this. Suppose you are at sea level, at sea level, okay, and you know that at sea level the ISA is how much? The ISA temperature is 15 degrees Celsius. Suppose the temperature on a particular day has gone to 20 degrees, okay, so it's not necessary that every time it will be 15 degrees. This is basically the international standard value, which is 15 degree. But suppose the temperature, actual temperature at the sea level has gone to 20 degrees, okay, so that is the actual temperature, which is your OAT, okay, on a particular day. So in that case, how much is the ISA deviation? Okay, so if you want to calculate the ISA deviation, okay, that is how much the actual temperature has deviated from the standard ISA. Okay, so for that, OAT minus ISA is the formula. So OAT is 20 degrees on that particular day, so I'm writing here 20 degrees Celsius, which is this one, minus ISA. So ISA at sea level is 15 degree. That's what we know. So it's 15 degrees Celsius. So how much it comes? 20 degree minus 15 degree. It comes to be 5 degree. That is plus 5 degrees Celsius. That means the actual temperature, which is 20, is plus 5 degree warmer than the ISA at sea level. Okay. So this is the ISA deviation, plus 5. Okay. Next, let's take another example. Suppose you are not at the sea level. Suppose let's make calculation at a particular altitude now. Let's take the same example of 3000 feet, okay, as we have discussed earlier. So suppose the altitude is at 3000 feet, okay. So at 3000 feet, if suppose the temperature is 35 degrees Celsius, okay, on a particular day, you know that the atmospheric temperature keeps changing at particular altitudes. So suppose someday the temperature at 3000 feet is 35 degrees Celsius. So in this case, how much is the ISA deviation? So in order to calculate the ISA deviation, first you should know what is the ISA at 3000 feet, okay, and from that ISA, how much the actual temperature has deviated, that is 35 degree. That means how much is the deviation. So let's first understand how much is the ISA at 3000 feet. So the ISA at 3000 feet we have already discussed earlier. At 3000 feet the ISA will be 9 degrees, okay. So let's make the calculation. So ISA deviation at 3000 feet is equal to OAT minus ISA, right? So OAT is 35 degrees Celsius minus ISA. How much is the ISA at 35,000 feet? So for ISA, if you have not done this calculation, then let me write the formula again. So for ISA, the formula is 15 degree minus 3 into lapse rate, okay, which is 2. So it comes to be 35 degrees, okay, minus, now this is 15, 3 to the 6, so how much it comes? 35 minus 15 minus 6 is 9, 35 minus 9 is 26 degree Celsius. So it is 26 degrees Celsius, this is plus, okay. So what is the meaning of this? So ISA deviation at 3000 feet is plus 26. That means the ISA deviation is plus 26 degree warmer than the ISA at 3000 feet, okay. So ISA at 3000 feet is 9 degree, okay, and the the ISA deviation is plus 26 degree. So moral of the story, at 3000 feet, if OAT or actual temperature is 35 degrees Celsius, then the ISA deviation is plus 26 degree warmer than the ISA temperature, which is 9 degree at 3000 feet. Okay, so this is one case. Let's take another example. Okay, suppose this is example number 1 at sea level, example number 2 at 3000 feet with OAT of 35 degrees Celsius, and third example at 3000 feet. Suppose the OAT has changed, okay, on a particular day it has changed to suppose 8 degree Celsius. Okay, so in this case, what will be the ISA deviation? Let's calculate. Okay, so ISA deviation using the same formula, okay, which is OAT minus ISA. Okay, so OAT minus ISA, OAT is 8 degree here, and ISA is how much? OAT I have written, minus I am copying it here instead of ISA. The formula of ISA I have taught you here. Okay, so what is the formula? It is 15 degree minus 15 degree Celsius minus this 3, okay, because you have 3000 feet multiplied by the lapse rate, which is 2. Okay, so this is the formula for calculating the ISA at 3000 feet, right? So the same thing is written here. So this comes out to be 8 degree, okay, minus 53 to the 6, right? So 15 minus 6 is 9, okay, and this comes out to be minus 1 degree Celsius. So that means the ISA deviation is minus 1 degree colder than the ISA. Okay, so what did we discuss over here? So in case of the temperature being 8 degrees Celsius at a particular altitude, suppose 3000, if we calculate the ISA deviation, so in that case we are getting the ISA deviation to be minus 1 degree, okay, that is cooler than the ISA. Okay, so we have discussed this and this case. In this case, the ISA deviation was plus 26 degree warmer than the ISA. Okay, and in this case, okay, when temperature OAT has changed to this value, in that case the ISA deviation is minus 1 degree cooler or colder than the ISA. Okay, so that's how we make the calculations for the ISA deviations. I hope you can make many more calculations based on the ISA. Let's go ahead with next calculation. Okay, now what we are going to discuss is about the pressure altitude. So I am writing pressure altitude, okay, or PA, okay, pressure altitude. Now what is pressure altitude? Pressure altitude is that altitude which you see on the altimeter whenever you set the altimeter to 1013 hectopascal or 29.92 inch mercury. Okay, so if you're in the cockpit, just set 1013 hectopascal, okay, or 29.92 inch mercury in the altimeter. If you're at a particular flight level, then whatever altitude you see, that is basically the pressure altitude. So that's one of the way to compute, or one of the way to check the pressure altitude. The other way, you can make a calculation by using a certain formula. Okay, so there are two ways to get the pressure altitude. One is by setting 1013 hectopascal or 29.92 inch mercury on the pressure altimeter, and the pressure altimeter then will show you the pressure altitude. And the other way is by using a formula, and that formula is, I'm writing here, okay, pressure altitude is equal to elevation, okay, airport elevation, plus 27 times 1013, that is the standard pressure setting, minus Q and H. So let's take some example to calculate the pressure altitude. Example number 1, suppose the QNH is 993, okay, and suppose the elevation, which is your airport elevation, is suppose 3000. Okay, so in this case, how much will be the pressure altitude? Let's see. Pressure altitude is equal to, you can see here, elevation. So elevation is 3000, so I'm writing here as 3000, okay, plus, I'm writing here plus, here it's written as 27. Why this 27 is written here? Why in this formula 27 is chosen? Let me tell you. So let us just pause this topic as of now and let's go back once. Here in case of international standard atmosphere, I have told you that the temperature it used to reduce at a rate of 1.98 per 1000 feet, right? And that is called as the lapse rate. Likewise, in case of pressure, with change in altitudes, for every 1 hectopascal, okay, if I see the altitude, it changes by 27 feet, okay. But for the main purpose of our calculations, we don't use 27, we consider this to be 30, okay, so that our calculations will be easier. So instead of 27, I'm writing here as 30, okay, though I can write that as 27. So in some books, you'll find 27 written here in the formula, and some you'll find 30, okay. So basically that's to make the calculations easier. So what you see is 3000 is the elevation which I have written here, okay. This elevation is 3000 on example, so I have written plus sign I have copied. Instead of 27, I'm writing 30 because I want to make calculations easier. Next is 1013. 1013 minus QNH. How much it is in our example? 993. 993. So let us compute this. 3000 plus 30. This minus this 993 and to 1013. It is how much? 20. So this comes out to be 3000 plus 3 2s are 600. So this comes out to be 3600 feet. So that's your pressure altitude. So this is the other way to calculate the pressure altitude. What was the first way? First way was on the pressure altimeter. You just set 1013 and whatever altitude is indicated, that's your pressure altitude. Okay, so basically all flight levels are the pressure altitude. Okay, like for example flight level 300, that's the pressure altitude. Next, what we have here is I have considered one example in which I have considered the QNS to be this much and elevation to be this much. So based on these data, you can calculate the pressure altitude. Moral of the story, if you want to calculate pressure altitude, you should have these figures, okay? Like your elevation and QNH should be there if you want to calculate the pressure altitude. Now let's talk about density altitude. Density altitude. What is density altitude? As the name says, density. Okay, so whatever is the air density, wherever the aircraft is operating, based on that density, okay, the aircraft performance is decided. We know that at different altitudes, the air density will change. It changes because of change in temperature or pressure. Now, if I talk about basics, you know that with increase in temperature, the density decreases. And also, you know that with increase in pressure, the density increases. So whatever would be the density, okay, wherever the aircraft is operating, okay, that will affect the aircraft performance. Now whenever I say aircraft performance, it includes certain things like your aircraft performance during takeoff, climb, cruise, descent. So all these things will be affected based on the density altitude. Basically density altitude is what the aircraft is feeling or experiencing, okay, and that's based on the temperature. So in one line, if I say density altitude is the pressure altitude corrected for non-standard temperature and also humidity. Okay, so for calculating the density altitude, we have a formula which is dA. I am representing density altitude by dA, which is equal to pressure altitude plus, okay, it is 118 point something, but instead of 118, I am considering 120 multiplied by the ISA deviation. Okay, so this is the formula of density altitude. So let's take an example to understand density altitude. Okay, now let's take an example to understand the density altitude. Okay, suppose the pressure altitude is 4000, okay, and the OAT is 40 degrees Celsius. So let us calculate the density altitude. Okay, so density altitude is equal to pressure altitude. So pressure altitude is 4000. So I'm writing here as 4000 plus 120 into ISA deviation. So ISA deviation at 4000, how much it will be? So if you want to calculate ISA deviation, we have already done that. ISA deviation is OAT minus ISA. So OAT in this example is 40, okay, 40 degrees minus ISA. Okay, so to calculate the ISA, what did I tell you earlier? It is 15 degree minus, okay, 3 into 2. So this is your altitude, pressure altitude, which is 4. So I'm writing here as 4 into lapse rate. So how much it comes? 4000 plus 120 into 40 minus, so 40 minus 7, so it is 120 into 33 plus 4000. So this will come out to be 12 3s are 36, 12 3s are 639, 0. This is 40,000, 7,960. Okay, that means if you are at a pressure altitude of 4,000, then density altitude will be 7,960 based on this temperature. Hence, moral of the story: density altitude is the pressure altitude corrected for the non-standard temperature, okay, which is this one. So if the pressure altitude is 4,000 with the temperature of 40 degrees, okay, actual temperature at this, then in that case the density altitude will be 7,960 feet. Remember that, friends, with the higher density altitude the performance of the aircraft reduces and vice versa. So friends, this is how we calculate the density altitude, pressure altitude, ISA deviation, ISA temperature at a certain level, okay, and the lapse rate. So friends, I hope you have understood whatever we have discussed till now. So let me quickly summarize whatever we have discussed today. We have discussed that the ISA temperature at the sea level is 15 degrees. Now this 15 degrees can decrease with the increasing altitude. And how does it decrease? It decreases by something called as the lapse rate, which is 1.98 degrees Celsius per 1000 feet. Okay, and for this, for the purpose of our calculation, we consider 2-degree decrease in the temperature per 1000 feet. Okay, that is the lapse rate. Next, after that, we have discussed how to calculate the ISA temperature at a certain altitude. To calculate ISA temperature at a certain altitude, this is how we calculate. We consider 15 minus this much. 15 is the temperature at the sea level minus 3. Suppose you are at 3000 feet, you take 3. You are at, suppose, 30,000, you will take 30 here. Okay, so I am considering 3 here because at 3000 feet multiply with the lapse rate, which is 2. And that's how you make the computation for the ISA temperature. After that, we have calculated what is ISA deviation. ISA deviations are basically to identify how much warmer or how much cooler, okay, the actual temperature is from the ISA at a particular altitude. So for that, the ISA deviation has a formula OAT minus ISA. So if you're at the sea level, the temperature will be 15 degrees, but suppose it has changed to some other value, then in that case, ISA deviation comes into picture, and through that ISA deviation, we can get to know how much actual temperature has varied from the ISA. It is in this example, it is +5 warmer than the ISA. So +5 degrees Celsius warmer than the ISA, it has varied. So likewise, we have seen some more examples, like at 3000 feet if temperature is this much, and at 3000 feet if temperature is this much. Oh, accordingly, the ISA deviations will be based on the actual temperatures. Okay, so in this case, okay, with 35 degree actual temperature at 3000 feet, the ISA deviation is plus 26 degree. Remember, it is plus 26 degree warmer than the actual ISA at 3000 feet, which is 9 degree, and at actual temperature of 8 degree, the ISA deviation is -1 degree cooler or colder than the ISA temperature at this altitude. Okay, then we have discussed how to calculate the pressure altitude and density altitude. For pressure altitude, there are two ways. One is by setting the pressure of 1013 hectopascal or 929.92 inch mercury on the altimeter, and then that's how we can get to see the pressure altitude. So all flight levels, whatever we see, okay, are the pressure altitudes. And the other way to calculate pressure altitude is by using this formula, wherein we require elevation and the QNH values to calculate the pressure altitude. So this is the formula for calculating the pressure altitude. Next is the density altitude, is what the aircraft actually feels. Aircraft altimeter may be showing 4000 feet, but actually the density altitude on which the aircraft performance is based will be at, suppose, 7,960 feet. Okay, so that's why density altitude plays a very important role, because performance of the aircraft is depend on a factor called as the density, right? So the density also, it changes with temperature and pressure. With increasing temperature, density decreases, and with increasing pressure, the density increases. So because of this, okay, the performance of the aircraft varies. And how does it vary? For that, we have a formula. Density altitude is equal to pressure altitude corrected for the non-standard temperature and humidity. Okay, and the pressure altitude, we have taken an example. To calculate the density altitude, we need to have pressure altitude and the temperature information. Based on that, we can calculate the density altitude. So friends, I'll come up again with a new topic in my next session. Till then, you enjoy learning this topic, and thank you.